Good morning, Annie. I just wanted to give you a short tutorial how to use the red underscore signi function in MATLAB to compute a significance test. So what I'm going to do here, very simply, I'm going to load, for example, the ANSO index, which I have here. So I'm going to do ANSO equals rout underscore ANSO. And I'm also going to load the PDO index. Now we know that ANSO and PDO have some correlation. So what I'm going to do now, ANSO is essentially an array that has time and different ANSO indices, and the PDO has this the same type. Sorry, I called it PSO, but let me just change that. And the PDO is a similar structure array that has index, the date nome, which is the time, etc. So if I want to compute the significance test, all I need to do is I take this stuff here. And I'm going to put it here. And then the input arguments of this function, which is also at the beginning of this function as a help, are essentially the time of the first time series and the index of the whatever the first time series S1 is, and time 2 and S2. So let's do that. So I'm going to say that here I'm going to have a PDO.dateNome, which is the time, and PDO.index. Then I'm going to put the ANSO component. I'm just going to increase this so that it's a little bit easier to see. ANSO.time and ANSO. In this case, let's say Nino 34. Now, the next argument in the function is this delta t. What delta t is, it's actually nothing magical. It's just the time step in the time. So my date nome here is essentially about every 30 days. It's in days, this array. So in this particular case, I'm going to use 30, which is 30 days. If this was just an integer, say from 1 to the length of the time series, then we would use 1. I'll do that example in just a second. The last input here is this num here that you see up here. This num is just the number of Monte Carlo samples that you want to use in computing essentially the statistical test. So I typically use 1500. This is typically a good number. But ultimately for the paper we could use something like 2500. So if I run this function now, it will generate, let me just close all my figures, close all, and let me run this again. So it's computing the PDF of the cross correlation using 2500 realization of 2 time series that have same autocorrelation as the time series that you put, and it's going to essentially make a plot like this, where here in blue and red are the 2 time series, is a Nino and PDO, and this is the probability distribution function of the cross correlation coefficient. It has 2500 samples. So this essentially is like if you took 2 red noise time series like the ANSO and the PDO time series, and you essentially compute correlations 2500 times, and then you plot what the correlation coefficients are. This is the spread of these correlation coefficients, or actually the probability distribution function. And so you can see that, for example, 0.42 is significant, is above the 99% level, and this type of information, which is plotted here, is also reported back to you in this particular output argument. So C99 here is the level of correlation above which you are at the 99% level, and C95 is the 23% level. And also signi, this function here, this actually tells you the exact significance of the correlation from this distribution. In this case is 100 because you can see that it just is way off the charts. If I were to compute, for example, a correlation, say with the PDO index, with the NPGO index in this case, ANSO and NPGO are not strongly correlated. So let's do that. Let's say time NPGO equals area out NPGO. And so we can recompute now this correlation, but instead of PDO, we're going to use the NPGO index. NPGO, and now you should see that things will be different. And it's computing the 2500 samples. So here we go. So there is a slight correlation of -2.4, but you can see that the correlation is essentially non-significant here. It's below the 95%. So once you run this function, all you need to look at is this particular output signi, which tells you the significance level. So this is 90% significant level. So this is how this function works. I wanted to come back 1 second to this dt because sometimes people are confused with this. So for example, here I used as the time array, time and ENSO time, which are in the MATLAB datenum format. So these are monthly time series. So in the MATLAB datenum format, these are 30 days essentially. If you wanted to just use, for example, and this is nice because this function will align these two time series in order to compute correlation. So it's nice if you just know the delta t. Otherwise, I think that's probably the best. So one thing to compute that, you just do, for example, if this is your time index minus time 1, this is going to be more or less your delta t. So in this case, it's 31 days because it's the month of 31 days, but if I use an average value. So it will depend, how you have your sequences and how you have your time array aligned. I hope this is clear. When you do this exercise, you may not want to, have a plot shown every time you run this. So I think that what you can do in the input argument, let me just do a quick test here. You can put as the last argument is 0, and I think that one. Let me make sure. I think it's going to avoid plotting the output. Right. So if you put as the last argument after the number of samples here, I just reduced it to 500, but you can use, as again I said, 2500. If you put a 0 as a very last argument, then essentially, this function will only compute the significance values without plotting, so you can actually put it in some kind of loop if you're doing the sliding correlation, and then your output signi will have the actual significance that you want to save. I hope this is sufficiently clear. If you can try this on your computer, it's probably easier, so you can actually do the exact correlations that or significance testing that you needed to. And one more thing, in terms of the text that would go with this type of test, of the significance test, is this part here that I sent in my earlier email. This is the exact test that you're doing. Okay, ciao Annie, hope this is helpful. Bye-bye.